Hello everyone and welcome back to the AWS Solution Architect Associate series. In today's video, we will explore the designing secure access to AWS resources. This is one of the most deeply tested sections on the exam because its identity and access security is fundamental to the AWS architecture. Let's jump right in. A secure AWS environment begins with strong access control. You will work with IAM users for individual access, IAM groups to assign common permissions, IAM rules for application, services, and cross-account access, and STS for short-lived temporary credentials. And for organizations using the multiple AWS accounts, this AWS Organizations provides the centralized governance, making it easier to manage security boundaries, restrict services, and apply consistent policies. These are essential components of secure and scalable access management. Large organizations rarely create IAM users for every employee. Instead, they use this federated access. With SAML, companies use providers such as ADFS, Azure AD, or Okta. And with OIDC, they integrate with modern identity solutions like Auth0 or Google. And AWS now encourages using the IAM Identity Center, which was previously AWS SSO, for central authentication. Federation maps the corporate identities to the AWS IAM roles and enabling the controlled, auditable, temporary access without long-term credentials. AWS global infrastructure matters when designing the secure access. IAM is a global service, that is, your users, roles, and policies apply to all regions. But resources like S3 buckets, EC2 instances, and RDS databases are regional, so permissions must reference the region-specific ARNs. You must understand which services are global versus regional, especially when designing the secure access models that span regions, workloads, and environments. To design secure access, you must apply the AWS security best practices. Always enforce the principle of least privileges, that is, never grant more permissions than needed. Require MFA, especially for the privileged accounts. Avoid long-lived access keys. Use IAM roles for applications and automation. Enable the CloudTrail and IAM Access Analyzer to detect unusual permissions or access patterns. These practices significantly reduce risk and align with the AWS well-architected guidance. The root user is the most powerful identity in your AWS account. AWS strongly recommends never using the root account for day-to-day activities. Enabling MFA for root immediately, not creating the root access keys. Using the root user only for sensitive tasks such as account settings, support, billing, and policy changes. A secure AWS environments start with protecting the root account. A flexible IAM authorization model is key for secure access. So use IAM users for humans, IAM rules for workloads, applications, services, or cross account access, IAM groups to simplify permissions for the teams, managed policy for common tasks, custom policies for fine-grained controls, permission boundaries to restrict the maximum allowed permission. Understanding the policy evaluation logic is important. There is explicit deny, which then allow, and then implicit deny. RBAC is essential for secure and manageable access models. Assign permissions based on roles and not individuals. Use STS assume role for temporary powerful credentials. Enable cross-account access by allowing one account to assume roles in another. For admins, role switching avoids maintaining the multiple passwords or keys. When federating with an external directory, roles become the key authorization layer. This model keeps the access clean, temporary, and scalable and auditable. Modern AWS architecture uses multiple accounts for security isolation. Using AWS Control Tower, you can automate the multi-account setup with service control policies, that is SCPs, to restrict the actions account across accounts, guardrails, which enforce preventive or detective controls, centralized logging for all the accounts, and isolated production, staging, and development accounts. This design prevents the accidental misuse and limits blast radius. Many AWS services support the resource-based policies, allowing the resource itself to define who can access it. Example includes S3 bucket policies, Lambda function policies, KMS key policies, SQS and SNS policies. Resource policies are ideal for granting and cross-account access, enforcing conditions, or ensuring only specific identities interact with the resource, that is, without modifying the IAM identities. Federating a directory service makes sense when you have many users and don't want to manage the IAM accounts. You need centralized identity lifecycle management. You want users to incorporate the credentials for AWS login. Permissions should be assigned automatically by the group membership. Federation paired with IAM identity centers enables a clean, secure workforce access with single sign-on and centralized role mapping. So to summarize, in this video, we explored how to design the secure access to AWS resources, covering IAM fundamentals, authorization models, STS, federation, multi-account governance, and resource-based security. These concepts form the backbone of AWS identity security and are critical for both exam and real-world architecture. In the next video, we will begin with designing secure workloads and applications, one of the most important sections of Domain 1. See you there. Thank you.